Hello and welcome to Geolytics. It's now August of 2023 and it's been 3 years since we launched the platform. Over those last 3 years, we've added a number of new features and improved existing features. The original explainer videos recorded 3 years ago are a little bit out of date, so we thought it was high time that we add some new content and show you how we use the platform today with all the new features. Today we'll be looking at an application of bridge deck analysis or rebar detection. Now, normally this is done with high frequency antennas, usually 800 or above megahertz antennas. In this case, we have an interesting data set from one of our users, Concrete GPR in Eugene, Oregon. Now, this same data set has some rebar in it, which we're going to use as a bridge deck analogy. So it's not actually a bridge deck, but we can do the same sort of processing. It also has some geological horizons and as well as some pipes. So we've recorded some videos on the other applications, but let's talk about the rebar at the surface for this video. So Geolytics is set up very much like Windows Explorer or Mac computer, where you'll have a root directory and then a series of folders or directories, and you can organize that however way you want, be it by client name, geography, date, whatever. In this case, I've sort of done it by client name as well as geography. And within that folder, I could have a whole series of other folders. In this case, I've just created a new project file. That project file is very much like a Word document or an Excel spreadsheet in that it contains all the information of that project. So inside that project, if we go into it, we'll see that we have a single layer, and that is our GPR profiles, but we can add many other layers, as you can see. Let's go into our GPR profiles, into our import. Now, to save us time, I've already uploaded a whole series of profiles. I think there's about 90 already uploaded. I have 2 more GPR profiles to upload. Now, this data set is from a GSSI 350 megahertz hyperstacking system. And there is no GPS attached to it. This is a traditional grid survey with lines in the X direction that all went from left to right and Y direction that all went from the bottom to the top. Now, Geolytics can handle any sort of geometry of a traditional grid system, be it reversed or multiple grids, whatever. But in this case, we have a very simple grid. And I've got 2 last files that I'm going to drag in here. Now, the GSSI files contain actually 4 files for the 2 profiles, right? There's a DZT and a DZX file. I'm going to drag and drop directly into my window here. Geolytics will look at it and determine their GSSI files and place them in the right place within their order. Now, I said that this is a traditional grid with lines in the X direction and the Y direction. So I'm going to create a new folder here for the X direction. And what I'm going to do is within my default folder, I know that lines, let me see my notes, 10 through 42 belong to the X direction. So I'll just drag them down into the X. I'll create a new folder here for the Y direction. And I'll select the remaining files. Remaining files will go into the Y folder. There we go. Okay, so now the default directory disappears because there's no files in it, and we have an X folder and a Y folder. That's great. Our next task is to position it. Now, I should add, if you have multiple grids in a very complex project, you could have files, say folders like X1, Y1, X2, Y2 for each grid, for example, if you're not using a GPS. If there is a GPS involved, then there are no folders. You're just dragging and dropping the files with the GPS tracks, of course, and everything's displayed. We'll record a new video on how that works shortly. But let's go ahead into the positioning. And what we see here is our 2 folders are listed, X and Y. Now, you could have called it left, right, and up, down, or whatever you want. Now, the X folder, we need to define and tell Geolytics what the geometry of the survey is. We know that the first line acquired was line 10, and it's the one at the bottom. It goes along the base of the origin, from the origin to the right. Okay, that's great. Now, what's the trace separation? Well, we can declare that what that is, or we can just use the embedded trace separation within the GSSI file. And if there was a problem with our odometer, let's say it was slightly miscalibrated, we can actually add a compensation here. In this case, let's trust that it was correct. Now the angle for the X files is at 90 degrees. And that's going to turn everything that way. And I happen to know that, well, we're in feet because we're in the United States, and the profile separation was 1 foot in this case. So let's go ahead and do that. Now, the one issue that we're going to have here is that my line 10, as we can see, is at the top. So I actually want to change the direction of my profiles and flip it around so the line 10 is at the bottom. Let's go ahead to the Y folder. And the only thing we really need to do there is put it in feet, make sure it's embedded trace separation, and it was 2 feet in that direction, and we should have our grid filled in. Let's just zoom in here. Now, if we had latitude, longitude position, we could actually add that to this and bring in a base map and georeference everything. But for the purposes of this video, let's just continue as we are. Now, we see nothing here. Well, what's going on? Let's go to process. And the first thing is we get this warning saying constant scale or normalization. So let's add a constant scale so we can actually see what's going on. And when we do that, oh, there's our data. This is all we really need to do to see the data from a GSSI system. The next part is we're going to do our time zero correction, which is simply add new process, time manipulation, and then time zero correction. Now we've got rid of the time zero and we push it right up to the top. So in our case, this is actually all we really need because we can see our rebar so clearly. Again, this was collected with a relatively low frequency antenna. This is a little bit of a unusual case. This is not usually how we would map bridge decks, but let's use this as an analogy. So the concept of bridge deck analysis, or even rebar in general, is that we want to look at the depth of cover, so that is the depth of the apex of that hyperbola beneath the time zero line, and ideally we also want to get an idea of the amplitude of that reflection. Why is that important? Well, as a general concept, the lower the amplitude, well, the less metal and the more the corrosion. Now, there's a lot more to it that we're not going to get into right now. In fact, it's not a linear. In fact, just because you have a lower amplitude doesn't mean you have corrosion. There's many other reasons that could create that, including surface coupling issues, increased moisture, or just a deeper rebar. But in this case, let's just use that analogy and use that assumption that we're trying to map depth of cover and amplitude. All right, how are we going to do that? Well, we have to pick each hyperbola, ideally. Okay, so, well, let's do that. So let's go to point interpretation, and let's give it a nice color here, maybe a blue, and we'll make them triangles, perhaps. And let's go ahead and pick them. Okay, here we go. 1. Oh, wow, this is going to take forever. I got thousands. There's 90 or 81 lines, and each one has hundreds of them. This is going to take too long. There's got to be a better way. And that's right, there is. So, you'll hear companies use the term AI, magical processing. Well, there's no AI involved here. This is essentially computer vision. And what we're doing is using an automated auto-discover hyperbola detection tool, which is essentially, looking at where hyperbolas are most likely to occur. It's not perfect, but let's see what we can do here. So what we're going to do is we're only interested in looking at hyperbolas in the upper 4 nanoseconds, right? So we don't need to see that deep. We just want to go the upper 4, something like that. Okay, and we want to try and get a little bit more forgiving so that the most number of hyperbolas are actually picked. Something like that. We're not going to get every one, but that's fine. Now, instead of just doing the current profile, we'll do all profiles. Okay, so give it a second here. And then let's go ahead and confirm. So let's see what happens now. What it's doing is it's going through each profile and trying to pick every one, which it did. Okay, but it's missing a few things. So the first thing I'm going to do is, in here, it's obviously kind of weak. So I'm going to add a depth scale to this. And the first thing I want to do is actually add a velocity so we know what our depths are. I'm going to try and pick that one. That's pretty close, I guess, something like that. Okay, So now when we look at our depth scale, what we'll also do is give it a maximum depth because that's not very deep. So we'll call it 50 centimeters so we can actually see things. There we go, we're starting to see things now. We can see we have a few outliers here. So what we would normally do is go through the point interpretation if we want to be very, very careful about this, and then fill in the missing ones and just make sure that we're not got any glaring mistakes. Now, I'm not going to do that for every one, but let's go ahead and take a look at that guy right there. Yes, there's an extra one, so you want to kill that and just sort of clean these guys up a little bit, right? Now, this is a laborious process if you want to do it very, very carefully. But in our case, I don't think it's super necessary because I think we can use what we have here and just kind of smooth out the errors. Okay, so we're good enough there. Let's go ahead and start making a map out of this. In fact, I'm going to change the scale. I'd probably get it down to about 3.5, and that should give us, well, maybe even less. Okay, 20 centimeters. There we go. Now we're starting to see something. So, well, we can see our depth of cover right now. It's pretty clear, but let's actually make a surface out of that. So we'll go to Depth Grid. We'll choose what layer we're interested in, point interpretation. And we'll use our automatic tool here, our magic wand, that'll tell us all the parameters we need. Let's go ahead and create that surface. So this is going to tell us, well, it's going to give us a surface in 3D, and this is all, of course, 3D aware. That's our depth of cover, right? And we can output that in any number of colors or whatever we want to do. That's easy. And color schemes, right? So let's say, I don't know, well, let's just reverse it. Okay, well, fine, you get the idea. But there's one more thing I want to do. I want to understand, is there corrosion going on? So that's too much. Let's go back to 0.1. Okay, so here we go. I'm actually going to clear this up by taking away my point interpretations. That's looking pretty good. So I'm going to add a new layer. Amplitude grid. This literally is a grid of amplitudes. So color scheme here, well, let's use something really bright, and we're going to use our point interpretation. Let's infill that again, and let's go ahead and do this. So now what we're interested in doing is mapping out our amplitudes, right, which is an analogy for rebar corrosion in a way. Now, I've got too much going on here, so I'm going to take away my depth grid. There we go, and I'm going to go down from the top down. So I've made a few mistakes. You can see these little bright spots. Those are obviously the wrong picks, and I want to get rid of those eventually. But you get the idea here that we're starting to make a map of amplitude. Let's actually smooth that map out. So I'm going to go to moving average, and I'm going to, because we don't need to know rebar by rebar, we're interested in generalities of, oh, that one's weaker and this one's stronger. So we're starting to see the picture build here, of course. Now, we don't have a great amount of range here. So what I might do is actually squish everything down so we can, there we go, that's a nice heat map. So you're starting to get the idea that we can map rebar intensity, which is essentially what bridge deck mapping is, fairly rapidly using this automated picking tool. So I hope this video has been helpful for you, and as always, reach out with any comments, suggestions, or questions, or if you need help in your processing. Thank you very much.